So there's the limit comparison test. This works on positive term series. If we have a series, it looks like it's close to geometric, but it's not quite there, then we can compare it with a geometric series and maybe we can get what we need. We can find out if it converges or diverges. If it looks like polynomials, rational functions with polynomials on top of polynomials, or maybe a square root thrown in, then we can just kind of take the largest terms and cancel everything out, ignore everything else, and compare it with a 1 over k squared, or a 1 over k, or a 1 over square root of k, or some p series, because we know the convergence and divergence of those p series. So those are the comparisons we'll try to make. We make them by taking a limit, and as long as the limit exists and is not 0 and not infinity, we're in good shape. We're good, and we know the convergence or divergence of our comparison test, and that means we know the convergence or divergence of the problem test, of the test that we were given as a homework problem. So you get to practice this a little bit. It's limits, so there could be L'Hopital's rule involved. There could be other things with the limits involved, but that'd be a good chance to review that if that's needed. But you'll get a chance to do some of these problems and get familiar with this test. This is probably the most common test that is used. I still recommend starting with the test for divergence. Just check really quickly and make sure the terms go to 0 before moving on to look for questions of divergence or convergence, because if they don't, we know we don't have to. We know that the series itself diverges. So there are 2 more tests that we'll take a look at tomorrow, and or actually Monday. There are 2 more tests that we'll take a look at, and that will complete the look at tests for convergence or divergence of these series.